All right, everybody, here's our first video of two videos on the volume of, actually, there's probably going to be more than two, on volume of three-dimensional shapes. Today we're going to try to hit the first two, and then I'll do a separate video on spheres because it's a totally different thing. Just so we're clear, a cylinder is a lot like well, first, volume is how much stuff goes into a three-dimensional object. So something like a plain old rectangle with no dimension to it, or I suppose two dimensions, a length and a width, this would be a two-dimensional shape. Something that has three dimensions would have a length, a width, but it would also have a depth. And we could create a box, and that box could contain things, and we would call that 3D. So whether this shape is going to be a cylinder like a can of soup, a cone like a sugar cone, like you'd get in an ice cream shop, or a sphere like, well, like a basketball. Whatever your three-dimensional shape's going to be, and however good or bad my drawings are, they're all going to be things that could contain things. Water, sugar, ice cream, air, doesn't matter. They could contain things. And to calculate the volume is to calculate how much they can contain. So today we're going to work on the first two and a separate video for spheres because it's a totally different thing. So the cylinder idea is very straightforward. I'm going to give you two examples of cylinders. They're both going to be very similar. I'm going to do them both in red, and then I'm going to do my cones in blue. So if you need to fast forward or rewind, the cylinders will be in red and the cones will be in blue. So we're going to start with the formula for the volume of a cylinder. And it's going to be pi r squared h. Now you'll notice that right off the bat, there's no pluses or minuses written on the inside. Heck, there's not even multiplies or divides. But when I have 1, 2, 3 symbols written right next to each other and no symbols in between, nothing here, that means we're multiplying. So this is pi, which is that 3.14159 ... irrational number we've focused on a little bit, multiplied by radius, which is from the outside of the circle at the top or the bottom. We call this our base. Even though it's at the top, you can imagine there's an equal base at the bottom, right? So we're talking about the base, and it's the radius of the base. So in this case, r is 9 in this example, and the h, not surprisingly, stands for the height. So you'd imagine that height and the radius, to some degree, have to kind of form a right triangle, or a right angle at least. So watch, this is very, very simple. So we're going to go ahead and we're first going to get, you see I used an equal sign here, we're going to get an exact answer first for volume. So we're going to go ahead and say volume is pi times my radius, which is 9, squared, so squared. I'm going to use a dot for multiply just to keep things straight. And then my height is 21. Now, just to keep things simple, I'm not going to write in the units with inches and inches, but I'm going to go ahead and I've already done some of this work kind of off screen. So I did 9 times 9 is 81. I did 81 times 21, and I got 1,701. You could, of course, try that out as well. And the pi, I'm going to write the pi right next to it like this. So it's 1,701 pi. And then volume is always going to be a three-dimensional thing. I showed that in the first slide. So this is going to be inches cubed, right? 3 dimensions. So this is what's considered the exact answer, volume. And I'm going to write down exact. It's exact because pi is not an exact number. It's well, I don't know if that's an accurate statement, but it's an irrational number. And there's no end to the number of decimal places we're going to have to use. So to write a volume in the exact form is going to probably involve the symbol pi. That's not to say that we can't then figure out what the volume of this shape is. And I'm going to go ahead and put approximate. And to do that, while once again I did the math off screen, I'm going to go ahead and take 1701 and I'm going to multiply by pi. Now I did it by hand. You could surely use a calculator for this. There'd be no reason not to. You could do it by hand as well. I ended up getting 5341.14. So 5,341.14, which is an approximate answer. Something that changes when you use approximate is you change the symbol to a kind of a squiggly equal sign instead of an exact equal sign. So the approximate volume is 5,341.14, again, inches cubed. Now I'm going to do a second example that's, and I should say, we're done, right? So there's the exact and there's the approximate volume of a cylinder. Now, if you need to fast forward to look for the cones, fast forward until you see me writing in blue. If you want to see another example, continue watching. And if you're still watching, it looks like you're looking for a second example. This one's a little different. Once again, I'm going to come up with an exact answer and an approximate answer. I'm going to begin with the formula pi r squared h. That is not a formula you need to memorize. That will be on your formula sheet. In this one, I need to find my radius. Now, here's my circle. So we're going to call this thing, even though it's laying on its side, we're going to call this the base. Or if you really felt like it, you could call this the base, right? You'll notice the bases are always going to be circles in these shapes. You'll also notice something different. The 10 here is pointing to a line that goes from one side to the other. You might recall that that's a diameter. Well, if 10 is a diameter, we divide that by 2 and we get a radius of exactly half that. So my radius is 5 feet. So I'm going to kind of make a box around that, and I'm going to keep that in mind. That's my 5 here, so pi times 5 squared. And my height is going to be at a 90-degree angle, so even though mine's tipped on its side, this must be the height. If we stood it up, it would make sense. So times 8. Now in this case, I'm going to go ahead and say that off screen again, I did the math. I did 5 times 5 and got 25. 25 times 8 is 200. So I got 200 pi feet cubed, and that is my volume exact. All right, so half the problem done already. To get the volume approximate, I'm going to say V sub approx, V sub SUB. When I write something down below and to the right, it's called a subscript, or math teachers would say V sub. V sub approx is approximately, there's my squiggly equal sign there. Now I did 200 times 3.14. Once again, I did that off screen, and I got 6.28. Oh, I'm sorry. 628.00. I don't need the 0.00, but it is still approximate because I used that 3.14. So I'm going to go ahead and say V approx is approximately 628 feet cubed. So if you watch the second example, hopefully you're good on cylinders. We're about to switch colors and move over to cones because this video is a little longer than the one before it. All right, for those of you that have been waiting for the blue marker and to deal with cones, the neat thing about cones is that the formula for the volume of a cone is, well, it's going to look really familiar. It's the same thing as the volume for a cylinder, but divided by 3. And the concept behind this, and I'm going to actually pull a problem that we've already done. The concept behind this is, if we had a cone, if we had a cylinder, and let's imagine that the center of the base at the top was marked at the bottom. And we were able to shave off all of this excess. Imagine putting it into some sort of a lathe or a spinner or a grinder or something so that we would just have this cone left over, like a birthday cap turned upside down. We would find ourselves with a third of the original volume. So if we're working with cylinders, we use the formula. If we're working with cones, we take that same formula and we simply divide it by 3. So I'm going to go ahead and take something that we've already done. So off screen, I have my original example, which was 21 inches, and we had a radius of 9. And we've already done the calculations. You can review and rewind if you need to. So V exact was 1701 pi inches cubed, and volume approximate was approximately 5341.14 inches cubed. Now you're going to perhaps be using a calculator here. I would probably use a calculator here as well, because here's the thing. A cone is not a cylinder. A cone is a dot at the base, bring these lines in, and imagine all of this other stuff on the outside is gone, and now we only have that cone. We have a third of the original thing. So quite literally, all we do is take this piece and divide it by 3. And when I were doing the divided by 3 part, I would do 1701 divided by 3. And gosh, I don't know what 1701 divided by 3 is. I should have had this done. 1 divided by 3 is a 5, is a 2, 18, and 21. So we get 7. So 567. So we get 567 pi inches cubed. And that's it. We literally just divided the original cylinder by 3, and now we have our exact answer. And we could do the approximate thing the same exact way. For this one, I am not going to do this one off screen, and I didn't do it, but you have calculators and you could do the same. This is, after all, just typing this correct number in, divided by 3, pressing equals, and you'll get your approximate value. So in the video here, you're going to feel a little bit left off, where I didn't complete the question, but I have no doubt that you could do this using some technology. And let's move on to a second example. Once again, if you don't need a second example, don't worry about it. But if you do, watch for a few more minutes, and that will wrap up our video. And the second and final cone video, cone example, I'm going to use the other cone concept. What if we had a cone on its side, and my drawing isn't really perfect, but you get the idea. We have a cone, it's kind of been tipped over one way or the other. And let's go and throw some numbers on here. This one I'm going to give I'll do it the same way I did before. I'm going to try and trick you. I'm going to give you a line that goes the whole way across, and I'm going to say that line is 4 centimeters. And I'm going to tell you that the cone, from the center of the base to the tip of the cone, is, let's call it 10 centimeters. Now this would be a pretty tiny little cone, but cones are sometimes small. So let's go ahead and use the formula. Volume is pi r squared h divided by 3. All right, divide by 3 because it's a cone. So here we go. The volume exact is pi times the radius. Let's see, if the diameter is 4, so our radius is divided by 2. So 2 equals the radius. Hopefully that makes some sense. So we're going to have 2 squared times the height is 10, and we're going to divide it by 3. So we have pi, let's see, 2 squared is 4, 4 times 10 is 40, so 40 divided by 3. So if I'm really going to be precise about this, I'm going to say 40 divided by 3 pi, or that's like 13.3 repeating pi. That's very precise. And our unit is centimeters, so centimeters cubed. That would be the exact. It's way over here, but that would be the exact, and how to do it. And then to find the approximate, the truth is, it's just like we did before. You could just take, in this case, since we've already calculated the exact value, just take your 13.3, and if I'm using a calculator, I'm going to probably go ahead and put a bunch of 3s into my calculator, probably as many as I can fit on the screen, and then I'll multiply by 3.14, which is why it's approximate, and I'm going to come up with, well, you can do the math. This is just calculation. This is just a number times another. We're going to have centimeters cubed, and you will have your approximate value done. That's it. So cones and cylinders, very similar. If you need to rewatch the video, the cylinders are in red, the cones are in blue, and I wish you the best of luck calculating volumes of both.